No idea. I don't remember
The
that.
bee's knees and the cat's pajamas.
There's a song called The
Yeah.
Bee's Knees by Pierce.
Okay, all right. So reviewed for this final, and I screwed up the video for 1 through 4. So we're starting with section 5, and I'll go back and add 1 through 4. So that's why this video is backwards. Okay, so evaluate the sum of the following finite geometric series. That's kind of a big clue. I need to know the multiplier. What is the multiplier here? Any term divided by the previous term gives me 2. Is the absolute value of 2 less than 1, yes or no?
No.
That's a big no. What does that mean?
I don't know.
Or does this even apply to this situation because it's finite?
It does not, I don't think.
It does not. This was the question that we would ask ourselves if it was an infinite one. So that was a waste of time. We can go straight to the formula. Now, how many terms are there? We need to figure that out. So we're going to take this 96 and we're going to figure it out. We know the first term is a 3, and we know the constant multiplier because you told me it was 2. And so we need to use some of our algebraic skills to figure out what that is. I know. We're traveling fast today.
I'll be honest, I don't have any algebraic skills.
Okay.
Divide by 2. Oh, 3, gosh darn it.
We got to divide out that first term, get rid of it.
I can't even write a number today. Hold you.
Okay. Now, I told you guys that you could either use logarithms or you could, because the number 32 is small enough, you could kind of guess and check. Okay? Just depends on what you want. Now, some of you probably will figure out that 32 is 2 to the 5th. So, what does that mean about n? How many terms are we dealing with here? Come on, 5 equals n minus 1, so what's n? Here, I'll write it out. 5 equals n minus 1. What's n? 6. That's right, there are 6 terms. So we're looking for the sum of 6 terms. We know the first term is 3. We know the common multiplier is 2. All I'm doing is following the formula, which would be up on the big screen when you're taking the test, right? S sub n equals first term times 1 minus r to the n power over 1 minus r. That'll be on the big screen for you guys to use while you're taking the test. So, using that handy-dandy calculator, what are you coming up with? A number, most likely.
However, that number is a mystery.
Do you think you could demystify it?
I can try with this handy-dandy calculator.
Hey, sounds good.
But don't tell me.
Yes, Miss
I want
Hall.
to figure it out myself. Hold on, don't tell
A wise man once told me.
Yes.
I did.
Tomorrow is a mystery.
me. Today, it is. That's a gift.
That's why
That is what they call it.
Today is a
Sorry,
gift.
gosh.
It's Master Uguay. Master Uguay.
Today is a gift, and that is why they call it the president. I'm pretty sure that's a Dr. Seuss quote. Pretty sure Uguay said it.
Yeah,
And then he turned into
Uguay.
some
Of course,
flowers.
Uguay, yes.
Master Uguay.
So if you'll please not disrespect our turtle, I would deeply.
He was actually a tortoise, so you're obviously not a real Master Uguay fan.
The original Ninja Turtle?
Actually, he was a turtle. Tortoises have flat feet. Turtles have fingers and nails, like Uguay.
He's a turtle.
Let me look some up here real quick.
Okay, wow. We digress in this video.
Uguay.
Okay, so Uguay said 189, right? Yes.
Giant Galapagos tortoise. Why does he have fingers? Tortoises don't have nails like that.
Okay, find me the multiplier. On question 2, what are we multiplying by? Any term divided by the previous term. Stop looking at Uguay.
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 Age. Around 1,000 years old.
Come on, what do we got for the multiplier? 1/2, thank you, is 1/2, the absolute value of 1/2.
Yes, it's less than 1.
It is less than 1, yes. Therefore, we do what? Use the formula. First term, right? First term over 1 minus r. And the first term's a 1, right? Stay with me. Okay. So, what do you get? 2. That's true. Very true.
Oh, wow.
There's an old math joke.
Oh, boy.
An infinite number of mathematicians walk into a bar. The first one says, I'd like a beer. The second one says, I would like half of what the previous guy got. The third one says, I'd like half of that. The fourth one says, I'd like half of that. The bartender poured 2 beers. Folks, that's what's going on here. That's what the joke's about. It's an infinite geometric series. We got 1 beer for the first guy, half a beer for the second guy, a quarter of a beer for the third guy, an eighth
It's
of
not
a
even
beer.
Ben at this point. They're having like a quarter of a beer.
Well, that'd be me because I can't stand beer.
The math cashier.
So, anyway, that's the old joke.
Disgusting.
I wouldn't know.
Thank you for including that in my video. Okay. Infinite geometric, what's the multiplier here in this particular one? 3. Yes, sir? Oh, you were just telling me 3. Is the absolute value of 3 less than 1? No. What does that mean?
The series diverges.
Series diverges. That's what that means. Okay? Don't waste your time if the multiplier is... Now, don't try to use that trick if you're talking about number 1. That's what I was making the mistake with at the beginning, because I was starting to ask that question instead of paying attention to the fact that it said it was finite. And realizing, oh, hey, it stopped. Whoa.
So it's finite. That doesn't matter.
That doesn't matter at all. You will go straight to the finite sum formula and work it out and be done. Okay, so is this arithmetic or geometric? 32, 16, 8, 4, 2, 1, 1/2. This is definitely geometric. Okay, what is the multiplier? It is 1/2. We have how many terms? How many terms, folks? It says so. 180. So we can use the finite formula, right? We need the first term. Does anybody know the first term? 32. We got 1 minus 1/2 to the 180th power over 1 minus 1/2. Using your calculator, find the mysterious value instead of a new number.
I've only got 6 months left. Keep it open eyes daily.
Yep. No, don't want that. I got 64. Does anybody else get 64 besides me and Mr. Wilkerson?
I probably will since you got 64.
I'm going to say yes.
Okay, it is 64. Yep. You were correct.
Boys. Is that it? We done?
I don't know. Oh, no, we're not done.
Oh, gosh darn.
Couple more here.
Goodness gracious.
Oh, they get the big E.
Okay, oop. Yep, summation notation.
The big E.
Okay,
It's actually called a sigma.
sigma.
I remembered that.
Yep, capital Greek sigma. So what's the multiplier? Can you see the multiplier? Can you see the multiplier tonight? It is where we are.
I feel like I got like a solid 60.
What? It is 2. Thank you very much. Remember, first term times r to the n minus 1. They gave it away. It's a 2. Is the absolute value of 2 less than 1? Yes or no? No. What does that mean? What?
It does not exist.
Sum does not exist in this dojo or any other.
Of course you don't. What was the last one? Was it arithmetic?
The last one was definitely not arithmetic.
It was geometry.
It was geometric, so we used the finite geometric formula. Okay. 5. Oh my goodness.
Last so long.
Cameron did that.
You should probably walk, unless it's really that bad.
I just pee before class.
Yeah. Uh-huh.
I did pee before class, but it's starting to come on a little bit. And it's kind of making me sad.
How many more?
I can wait until
We got. There's like one more question. Come on,
Yeah,
you
no,
can
I'll
stay
just
for
wait
one
till
more
the
question.
rest, and then I'll use the rest.
Okay. What's the multiplier? Negative 0.45. Is the absolute value of negative 0.45 smaller than 1, yes or no?
Yeah.
Therefore, we use the formula. All right, the formula says the sum of the infinite terms.
Sign this boy.
Are you filling this stuff out while I'm filling this stuff out? Come on, you're supposed to take notes. First term is, if you don't know what the first term is, what should you plug in? 1. What is negative 0.45 to the 1 minus 1 power?
1.
That is a 1. Thank you very much. So the first term is 1 over 1 minus, negative 0.45. 1 divided by 1.45. I don't know why I use parentheses. What'd you get?
160.
That's what I got. I don't know what you got. About 0.69. Thanks for writing it down. You know, so you have it in your notes. You better copy it when you get back.
Alright. A copy of it.
Yeah, that's fine.
Lucas, what copy of it?
Okay? Did that make sense?
Sure.
Okay. We're just typing it in our calculator.
Yeah, what'd you get as a number? Because I got a pretty big number.
I got 0.69.
I got 0.69 as well.
Yes.
Nice, Lucas. Ooh.
That is correctamundo. All right. And you guys can ignore the rest of this while I talk to the people about 1 through 4.
Are we done?
Well, we're done. Yeah, we got through section 5. Yes, please. Nice throw. It's like you're a thrower.
This is one of the start.
Okay. Try not to be vulgar while I talk to myself.
I won't.
Yeah, okay, that's good.
I'll try not to be loud.
Okay, that's good. Okay, so the first, if you want to find any of the terms in the first one, you plug in a 1, then you plug in a 2, plug in a 3, or once you plug in a 1 and realize what the starting one is, then you can see the slope or the constant difference between the terms is 10, so you can keep adding 10. Either way, that's what you would do for the question 2 or 1. Question 2 is recursive. We can see that you're multiplying by -3, so there's no way that it could be the adding or subtracting ones. So we can get rid of all those choices. Then you can see these have the wrong starting value, so you can get rid of those choices. So it was really down to A or H, and the one with the correct starting place and the correct multiplier of -3 was letter A. Question 3, explicit formula. Well, it couldn't be B or E because those are recursive formulas, not explicits. So those would be ridiculous choices. We needed to plug in a 1, 2, and 3 to find the one that would work. Someone suggested when we did this before that we use letter F, but we found that worked for the first 2 terms, but it failed on the 3rd term because we ended up with a 6 and we should have gotten an 8, so it didn't work. That's why we got rid of this choice. And then somebody suggested we go with D, and then we checked that one. We got 2, we got 4, we got 8. We were all happy. Happy. And then we, for the last part, the 8th term, we could just plug in an 8, and that's how we ended up with a 256. Let's see, what else? Okay, so that's section 1. Section 2, the arithmetic sequence, finding the missing term. If you're finding the missing term, you want to add them together and divide by 2. That's called the arithmetic mean. So we added the 9 and the 15 and divided by 2 to get 12. Determine if the given sequence is arithmetic. We decided it was arithmetic, and the common difference was 3. You take any term and you subtract the previous term. Any term minus the previous term. Every time you do it, you should get the same number, and we did. We got a 3. Question 3. Remember, all the formulas will be on the big screen while you're doing this test with your notes. Hopefully you brought your notes. If you want to find the 20th term of that sequence, you have to know the starting one, and you have to know the common difference, and then you can plug in the one that you're looking for, and we ended up with 84 seats in row 20. Now remember, that's not the same thing as the sum of all the seats in all the rows, so that's a different question. 14th term, we talked about this in class. If you have the 15th term and you know that going forward you're going to subtract 19 because that's what it says to do, then going backwards would be to do the opposite, which would be to add 19, and that's how we got the 14th term, which is 14, ironically. Question 5. Starting with negative 18 and common difference is negative 6. Find which term is negative 42. Okay, so we placed the negative 42 on this side of the equation and started solving. I know that there are some of you that want to distribute the negative 6. That's okay. I'm not going to answer it. One of you other children can, because I'm recording. Let's see here. I added the 18. What in the world was that? Added 18 to the other side, divided by negative 6, and added 1, and got the 5th term of the sequence. 5th term of the sequence. Recycle. Thank you. Section 3. We figured out the multiplier was 3, and so it is geometric. Boy, that was a tough question. Any term divided by the previous term, and we had to do it multiple times, and it worked out. Question 2, find the 4th term of the geometric sequence. I wouldn't waste my time coming up with an explicit formula for this. If I can see that the multiplier is negative 5, just use it and multiply by negative 5 to get the next term. That's all I would suggest you do. Don't waste more time. Missing term, multiply and square root. Instead of adding, divide by 2, which is what you do for the arithmetic. For the geometric, we multiply and take the square root, which is how we got 4. Question 4, write an explicit formula. So couldn't be choice A because it didn't have the correct starting term. Choice B was ridiculous because they had an n-1 for a subscript. It was like a horrible attempt at a recursive formula. And we found out it was choice C because it has the correct starting value multiplier and the correct exponent of n-1. I was trying to show you down here that you can use the calculator with the recursive pattern to get it to generate, and you just keep hitting the enter button. As soon as you get times 0.25, answer times 0.25 in your calculator, it'll keep multiplying by a quarter and then generate these 5 terms pretty quickly. You don't have to go back to the explicit formula every time. So the job offer question, not too hard. We know the first term is 33,000. They give me the multiplier of 10%, which is 1.1. So they hand that to you. And we know that we're looking for the 4th year on the job, so I just plug in a 4 for n, and it spits out 43,923. So That was a pretty nice geometric one. All right, and lastly, we're on section 4. Try to get through this question so that the children can talk. We don't know how many terms there are, so that's the first thing we did. We took the 40 and set it equal to first term plus common difference times n minus 1, and then we started through the process of solving, where we moved the 4 over to the other side. That's how we got 36. Divided by 3, that's how we got 12, and then added 1 to get 13. And so we could get rid of any choice that did not have 13 terms. And then we had a really cool lesson by one of the students in class about why it had to be this one down here, because if you plug in a 1, you get 4. If you plug in a 2, you get 7. If you plug in a 3, you get 10. So just plugging in a couple numbers. After I know there's 13 terms, then I just have to plug in numbers like 1, 2, and 3 and make sure that what I get is the values that I've been told about. Question 2 is a little Carl question. We just didn't know how many terms there were, so we had to figure that part out first. So we took the 107, set it equal to first term plus common difference times n minus 1, and started the solving process. Subtract 5, divide by 6, and then added 1 to get 18 terms. And so we used that in little Carl's formula. We knew the first term was 5, and we knew the last term was 107, and that's how we ended up getting our 1008. Just using little Carl's formula, which will be on this big screen, you know, coming to a theater near you. First term, first term plus last term. Are they all asleep? You guys, this is as quiet you guys have ever been. This is pretty cool. Except during a test. I feel like there's more noise during a test than this. But, you know, you guys are being nice to me. That's very nice of you. Very kind.
No, you were recording video.
I know. So, there's 90 terms. That was pretty obvious from the top there. It's another little Carl situation because it's an arithmetic series. We can find the first term by plugging in a 1. And that's what I was trying to indicate with this arrow right here, is that I'm plugging in a 1. That's how we ended up with -3. And to find the last term, we plugged in a 90, and that's how we got 264. And then we could actually type this on our machine. And what did we end up with? 11,745. The amphitheater question, which is kind of like the one we talked about before. So we've got 15 seats in the first row, so we know that much. We did not know how many were in the last row. We knew that there were 34 rows because they told us that much. But we didn't know how many, so we actually had to calculate it. So we knew first term was 15, common difference was 3. We plugged in 34, and this thing gave us 114 seats in that last row. So then we could put that into the last piece of little Carl's formula to get our 2193. So close. Hey, we are done. All right, cool. All right, so that's the review for the final exam.